Hello, everyone. I hope I am live now. So, a very good evening to all. And I'll wait for a few minutes so that everyone will join. It's just the correct time, 8 p.m. So, we'll wait for maybe 3, 4 minutes so that you join here. And then maybe we'll start our today's session. It's the continuation of the previous session, which I have conducted day before yesterday. है ना जहाँ पे we have discussed about the fundamentals of binary search tree, and we have talked about the insertion part, searching part, and the properties that we have for BST. The only thing which was left in that previous session was how we can do the deletion, right, in the binary search tree. And let me tell you, this is one of the most widely asked question in interviews also, and many people used to get afraid that how the deletion will happen. So before we will start, I really want everyone to just confirm to me whether I am clearly audible or not, right? And then maybe after 1 or 2 minutes, I'll start the session where I'll first of all try to give you an idea that how basically whatever things we have talked about, we have learned so far. I'll give you a brief overview, and then maybe we will start with the today's agenda, that is how we can do the deletion in a binary search tree. I hope that you all are excited with me to learn in this particular session as well. So please stay tuned. And what I'm doing is I'm trying to share my screen within that period of time. If someone will give me the confirmation that whether I am clearly audible or not, that would really help me to understand that whether I am clearly visible, I am clearly audible or not. Okay. So meanwhile, I'm trying to sharing my screen. Okay. So I hope my screen is visible now. As far as I can see from my second screen, this is visible properly. The very first thing is that whatever session I have conducted day before yesterday, this recording is available in the same playlist of DSA using Python. Okay, this was the session understanding BST, insertion, searching, and interview question. Second session, which we are conducting today, is also in the same series of this playlist: live coding, mastering BST, and complexity analysis. Okay, so everything is also available in a recorded mode. The only beauty about the live sessions is that you can ask the queries on the live, and I will try to respond to you on the spot, right? And apart from this, I believe so far so good. Whatever be the session notes I have used, I have tried to attach those session notes in the if you will see description of the video, where in the comment section, if you will observe, if you will go to the live session notes and if you will click on this, you will be able to get my GitHub repo where I have uploaded everything for that session, which was connected day before yesterday. So if there is someone who is looking for a complete in-depth knowledge and have missed the previous session, I would suggest please go and check it out, this particular session. Again, a very insightful video where you will be able to get the fundamentals of BST as well as how we can do the insertion and deletion in a BST. Okay. So I hope it is clear to everyone. Now, without any delay, let's get started with the today's agenda. Can you guys give me the confirmation? Am I audible? I want this session to be more interactive. So I really want you guys to, make sure that do mention in the comment section or in the chat window that whether everything is clearly visible, audible, understandable, clear or not, right? So that I will get the confirmation, because it's in a virtual mode. So I will be only able to get the confirmation from you guys, then only I will move ahead. Okay. So can you guys confirm to me, those who are watching me live, that whether I'm clearly audible, my screen is clearly visible, and I'm clearly visible as well? So Karan's give me the confirmation that I'm clearly audible. That's great. Now let's get started. What's the time now? I think it's 8:04. Fantastic. I think those who want to join live, they have definitely joined. If you want some of your friends to let them know, please do let them know. I'm starting the session. And apart from this, as I already have shared, that recording will also be available after the session. If at any point of time you want to rewatch the video, please go and check it out in the DSA with Python playlist. Everything is in that playlist is available in the series. Okay. So let's try to understand what is the meaning of a deletion. And here I'll try to split the deletion into two parts. डिलीशन को हम दो कंपोनेंट्स में डिवाइड करेंगे, दो केसेस में डिवाइड करेंगे. ओके, so let's consider that I will take one binary search tree. Let's try to create that first, and then maybe step by step we will talk about that how we can do the deletion of that. Okay, so let's say कि मेरे पास में elements है. For example, the very first element which I have is 100. So you all know that this 100 will become the root node. Now the next element that I have is, let's say, 70. Now you all know that this 70 is smaller than the root node, the parent value. And what this BST says, what's the property of a binary search tree? It says that the element which is smaller than the parent node will be always at the left side. So those who are following me from the last session, they definitely know about this property. So BST says that whatever be the element which is smaller than the parent node will always be at the left side. Whatever be the element bigger than the parent node will always be at the right side. So I will place the 70 at the left of 100. Now let's move ahead. The next element is 120. So this 120 is bigger than the parent node. So obviously I will move it towards the right side. Next element is 50. So what will happen? 50 will be placed at left side of 70. Next element is, let's say, 75. So what will happen? Again, you have to always start from a root node. You will say 100 is there. Okay, I want to insert 75. It is smaller than 100. So I will move towards the left side. Again, the next element is 70. Now again, you will compare that the element that you want to insert, which is 75, you will try to insert it at the right side of 70. Make sense? Right? Next element is, let's say, 110. So if you will observe here, 100 right side is 120. 110 is bigger. So I will move towards the right side, then the left side. Now those who are following me from the very first session, I think they will be easily able to understand what I'm trying to convey here. So let's say 125. So 125 will be here. So in this way, now this is something which we have is a valid binary search tree. Can I say, everyone? This is something which we have is a valid binary search tree. Now I'm trying to split the deletion part into two cases. Okay, please try to understand from this session, from this particular part, and try to watch this until the very end so that you will be able to get the clear clarity, because many people are confused in the deletion part and they really find it difficult. Okay, so the first case is, the case number one is that, let's say you want to delete a leaf node. Case number one is that you want to delete a leaf node. Okay, in a tree, what is the meaning of a leaf node? In a tree, what is the meaning of a leaf node? The simple meaning of a leaf node is that the node which is having no further child nodes, right? For example, if you will say 50 is a leaf node, 75 is a leaf node, 110 is a leaf node, 125 is a leaf node. Let's say you want to delete 75. So what will happen? How will you do the deletion? Very simple step. Very simple step. First of all, so I'm saying, let's say I want to delete x is equals to 75. So this is the element I want to delete. So what I will do? You will say that the very first thing which you should do is you need to search for the element 75. अरे भाई, जो element अपने को delete करना है, whatever element we want to delete, first of all we need to search that, right? At which particular place that element is present. So what you will do? You will start from this 100. Now you all know how the searching will happen, right? You all know because we have already discussed that part. 75 value is smaller than 100. So you will go towards the left side. Then next element is 70. So you will go towards the right side. You will be able to find out the position where the 75 element is there. Now what you will do? You will simply delete that. You will simply assign that node value as null. Simple. And the deletion is happening, right? What you will do? You will simply assign this value. You will go to this position and you will assign this as null. And deletion is done. So simple. So if the case number one is there, it's quite simple. The only thing which we're supposed to do is we're supposed to move towards the leaf node. First of all, we need to search for the position. If that is a leaf node, how do you get to know? If the left of that node and the right of that node is null, it means that there is no child node, it means that it's a leaf node, and at that point of time you will assign that particular node value as null. Simple part, deletion is done. Second case, that's a very important case, where you want to delete a known leaf node. You want to delete a known leaf node. What is the meaning of known leaf node? A node which contains a child value. अब वो child एक भी हो सकता है, दो भी हो सकते हैं. As you already have learned, binary search tree is a binary tree which contains at most 2 child nodes. तो 0 भी हो सकता है, एक भी हो सकता है, दो भी हो सकते हैं, right? So now when we are talking about a known leaf node, what will happen? See, there are two options which we can have. Let's say you want to delete a value 100. Let's say you want to delete 100. How deletion can happen? This is a very, very important case, and many people are confused in this case. So please try to watch this part very well, okay? And if you got any sort of doubt, do let me know. Now, 100 is a known leaf node. I hope everyone knows this stuff, right? Now, I want to delete this 100. So let me try to create this node again, this tree again. 100 is there. On the left side, I will be having 70. On the right side, I will be having 120. On the 70 is left, I will be having 50. On the 120 is left, I will be having 110, right? And on the right side, I will be having 125. 125. This is a valid BST. I have deleted 75 until so far, right? Now I want to delete this 100. Can anyone tell me what should I do? See, the deletion should happen in such a way that the property of a BST is retained. जो property हमने पढ़ी थी binary search tree की, वो retain रहनी चाहिए. That should be retained. You should not violate that property of a BST. So can anyone tell me, if I will delete this 100, I want to delete this 100. So first of all, obviously, the same process will happen. I need to search for that particular node which I want to delete, which is 100. That's fine. Now, what should I do? What's the next step? I started searching. I will be able to get the element. This is 100. Now, how basically I will be able to retain the property of a BST in this case when I delete the element 100? Can anyone give me an idea? Whosoever is watching me live. हम क्या करें ऐसा कि जो 100 डिलीट करने के बाद जो बीएसटी की प्रॉपर्टी है ना, वो रिटेन रहे. रिटेन रहने का मतलब है कि लेफ्ट में हमेशा जो एलिमेंट्स हैं वो स्मॉल हो और राइट में हमेशा जो एलिमेंट्स हैं वो बिगर हो. तो ऐसा मैं क्या करूं? सो अंकित शाह इज सेइंग दैट लेफ्ट राइट रोटेशन. और ओके, यहां पे हम कोई एवीएल ट्री या फिर रेड ब्लैक ट्री की बात नहीं कर रहे हैं, तो रोटेशन का कॉन्सेप्ट तो आएगा ही नहीं. वी आर नॉट टॉकिंग अबाउट हियर एनी सेल्फ बैलेंसिंग ट्री लाइक AVL और रेड ब्लैक. So rotation concept is not coming into picture. See, there is a concept of something called as a successor and predecessor. That's what I want to explain, and that's the real agenda of today's session. Please try to listen it very carefully. The one way which you can say to me that, Priya, what you can do is go towards the right subtree, and try to find out the minimum element in that. What I'm saying, go towards the right subtree of the node that you want to delete and try to find out the minimum element in that. Try to find out the minimum element in that subtree. So how will you able to get the minimum element? That will always be present at the left side, which is 110. So what you will do, you will say that I will replace this 100 with 110, and then I'll move towards right and just remove this. So what I have done, the first answer which I got by moving towards right subtree and getting the minimum is 110 is there. On the left side, 70 is there. More left, 50 is there. 120 is there. And 125 is there. Right? So basically, क्या किया मैंने यहाँ पे? मैंने एक सिंपल बात बोली कि जो नोड मुझे डिलीट करनी है, मैं उसके राइट सबट्री में जाऊंगी and I will be able to fetch the minimum value. वो क्या है? लेफ्ट में प्रेजेंट होगी, जो कि इस केस में, इस एग्जांपल में 110 है. उससे मैंने 100 को रिप्लेस कर दिया, एंड वंस आई रिप्लेस दिस, फिर से मैं राइट सब ट्री में जाऊंगी और जो 110 है उसको मैं डिलीट कर दूंगी, नल के इक्वल असाइन कर दूंगी. एंड दैट्स व्हाट आई विल डू इन द कोड इंप्लीमेंटेशन आफ्टर अंडरस्टैंडिंग दिस पार्ट. ओके, सो इसी चीज को हम बोलते हैं, इस वैल्यू को जो 110 हमारी निकाली उसको हम बोलते हैं सक्सेसर. ये क्या आया हमारे पास में? सक्सेसर आया. दिस इज व्हाट वी कॉल्ड एज अ सक्सेसर. ठीक है. So if someone will ask you what is the meaning of a successor, I hope now everyone will be able to understand. Second way by which we can solve this problem is, you will say that what I will do is now, I will go to the left subtree. I will go to the left subtree and will try to find out the maximum value or maximum element present in the left subtree, which obviously I will be able to get by getting the right side scanning. So you will go to the left subtree and you will be able to get the maximum element, जो कि यहाँ पे क्या है? 70 है. So what you will do is, you will try to replace this value 70 with 100. So in other words, what you are doing is, 70 is the root node. On the left side, you will be having 50. On the right side, everything will remain same. 120 is there, 110 is there, 125 is there. So in a way, you will be able to get two results. This is the result number 1. This is the result number 2. And if you will observe in both of these results, the property of BST is retained. अगर आप यहाँ पे दोनों में देखो तो जो BST की प्रॉपर्टी है बाइनरी सर्च ट्री की, वो रिटेन्ड है. लेफ्ट साइड में सभी के सभी एलिमेंट्स क्या है? स्मॉलर है. राइट साइड में सभी के सभी एलिमेंट्स क्या है? बिगर है पेरेंट नोड के कंपैरिजन में. एंड दिस इज समथिंग व्हिच वी कॉल्ड एज द एल्गोरिथमिक टर्म predecessor. So either you can solve this problem of deletion via successor. अगर आपके पास में रूट के राइट में नल वैल्यू नहीं है तो you will be easily able to get the successor value. अगर रूट के लेफ्ट में नल वैल्यू नहीं है तो you will be able to get the predecessor value, and then you can try to exchange the values and you will be able to get the deletion result. Is this part is clear to everyone, guys? क्या समझ में आया सबको मैंने क्या बोला यहाँ पे? This case number 2 is very, very important, where either we are doing a replacement with the successor or we are doing a replacement with predecessor. Very, very important. What is the meaning of successor? Moving towards right subtree and finding out a minima and replacing with that. What is the meaning of a predecessor? Moving towards a left subtree and trying to get the maxima. तो हर बार हो सकता है कि आपके दो रिजल्ट्स आएंगे. हो सकता है आपके फ्रेंड का रिजल्ट अलग आ रहा है क्योंकि वो रिप्लेसमेंट कर रहा है राइट सबट्री में जाके, और हो सकता है आपका रिजल्ट अलग आए, बट दोनों रिजल्ट्स ही वैलिड है. बोथ द रिजल्ट्स आर वैलिड. ओके, summary is, if we scan left side, largest value is the root node and smallest for the right scanning. Yes. And the literal term for these things is predecessor and successor. ठीक है. तो कई बार क्या होता है कि लोगों को लॉजिक पता होता है पर टर्म नहीं पता होता. So this is important to know the term as well. Okay. समझ में आया? Is this clear to everyone how we can do the deletion? Shall we do the implementation now? So Ishan is saying, hi Priya, I'm a big fan of you. Thank you so much, Ishan. Hello, good evening. Perfect. I think I have read all the comments. Shall we now move ahead with the implementation part? Can you guys give me the confirmation? So whatever things just now I have talked about, let's try to do the implementation for the same, okay? So I'm again going back to the lead code screen where, so I am sharing the screen with you as well. Sorry, the URL of this particular question as well. I am sharing with you all. So let me do one more thing. Let me just pin this comment. Perfect. I have pinned it. Now, sure. Let's try to do the implementation of this particular part. So this is saying the same thing, that given a root node of a reference of a BST and a key, delete the node with the given key in the BST. तो अपने को पता है अब delete कैसे होगा. सबसे पहले we need to do the searching part, then we need to do the cases part, case number 1 and case number 2. We have understood. So they have written down this thing as well. Basically, deletion can be divided into two stages, जो अभी अभी मैंने बताया. First of all, you need to search for a node to remove. Second, if a node is fine, you need to delete the node. Now, you need to understand whether that node that you want to delete is a leaf node or a non-leaf node. Accordingly, you will write the code, right? So let's try to now write the code for the same, right? Let's focus on this part. Is everyone ready? Shall we start now? So, first of all, what's the base case condition? What is the base case condition? Base case condition can be, let's say if the root value is none. If you want, you can also try to write the code with me. Okay. Let's see who are the guys who will be able to get the correct response from the lead code platform. So if the root is none, obviously we will be able to return the none itself. If that's not the case, right, then what we should do? At that point of time, the first step is to search for a node to remove. Make sense? So how we can do the searching? I think in the last session we have easily explored. We can say if the key is bigger, let's say bigger than the root.well. Now let me know if the key is bigger. In that case, should I traverse towards the left side of a subtree or a right subtree of a tree? Anyone who can tell me? If the key is bigger than the root.well, then what we should do? Should we explore towards the left subtree or the right subtree? If the key is bigger, obviously we need to traverse towards the I believe everyone should say right subtree, right? So in this case, what we will do, we will say root.right, which is equals to, I will call the function again. I'm using a recursion here, delete node, where I will mention the parameters root.right, comma, the key which I am exploring. So Karan is also saying right, which is correct. Make sense? So we have made a recursive call towards the right subtree. If that is not the case, elif, let's say the key is lesser than the root.well. In that case, what we should do? If the key is smaller, as per the BST property, I need to traverse towards the left subtree. So what will happen? There will be a recursive call towards the left subtree. So what we will say? We will say root.left, which is equals to delete node, and inside this we will call the function root.left, comma, key. Make sense? Now if that is not the case, in else case, see, this is the scenario where I know that, okay, here while calling the function, we need to use the self keyword because we are using a Python programming language here to implement. Now, here if you will observe, if the case number 1 is not there, the case number 2 is not there, in that case, I am pretty sure that I will be able to get that node which I want to delete. Now we have to see that either we will talk about case number 1 or case number 2. For that, what I will do, first of all, I'll check whether a search node is a leaf node or not. So if it is a leaf node, what will happen? What's the condition of a leaf node? Leaf node says if the root.left is none and the root.right is also none, right? Then only you can say that there is no child node. When the left portion as well as the right subtree both are none, then only we can say that it's a leaf node. In that case, what I will do, I'll simply mark that root as none, which indicates that, okay, you are done with the deletion part. So this is the case number 1 that just now we have discussed, where we want to delete a leaf node. Let's talk about the case number 2. Case number 2 is that I want to delete a non-leaf node. In that case, what I will do, I'll just check it out let's say my root dot right is not none, is not none. In that scenario, what I will do? अगर मेरा राइट सब ट्री का वैल्यू नन के इक्वल नहीं है तो मैं क्या करूं? राइट में मैं सक्सेसर लेके आ सकती हूं. I can find out the successor value. So what I will do in that case, I'll say root dot val is equal to, I will call one method called as successor, right? What we will do, we will try to take the successor function which will give me the value, means right subtree mein jaake it will be able to fetch the minimum value, right? So what I will do is I'll call one function, I'll define this function above, self dot successor, and inside this I'll just pass the root value. And then what I will do, I'll move towards the right side because I need to delete that element. So what I will do, I will call self dot delete node. Delete node, this is the method name. I will move towards the right side, followed by comma the value that I want to delete, which is root dot val. Now this is important to understand what we have done here. How many of you have understood what I have done here? How many of you have understood? How many of you have understood what I have done here? Basically, a very simple thing which we have done. The very first thing, सक्सेसर ने हमें वैल्यू दिया 110. मैंने क्या किया? मैंने इसको स्टोर कर लिया किसमें? रूट डॉट वेल में, राइट? Once I have stored this, I said to my code, go towards the right subtree and delete this part. Again, I have called my recursion and I said, go towards the right subtree and delete this part. That's something which we have done. Same thing we can do for the left subtree as well, right? So what we can say else do one thing, root dot val is equal to self dot predecessor. Inside that we can pass the root, and then what we can do, we can say root dot left is equals to self dot delete node. Inside this we can say go towards root dot left and remove that root dot val value. That's it. Finally, once we will move out of this, we can return the root. Now the only thing which is pending is to define this function successor and predecessor. So let's define this function. First of all, let's do the method definition of successor. See, many people usually find this code very, very difficult. But if you will try to understand from the scratch the things, how it is going up, it's very, very easy to understand. So let's try to write the code of successor where we will be having self followed by the root. Now, what is successor? Right subtree में जाना सबसे पहले. Root is equals to root dot right. So what I will do? I will move towards right. पहुंच गए. अब minimum value निकालनी है. So how we will be able to get the minimum value? We will say until or unless my root dot left is not equal to none. Do one thing. Move towards the left. Root is equals to root dot left. तो इससे क्या हुआ? I will be able to get the minimum value because I know that minimum value will always be present at the left side, right? Finally, what we can do once we return out of this while loop, we can return root dot val. Similarly, what we can do the method definition of predecessor. So what we can say, def predecessor self comma root, and here first of all we will move towards the left side, and then we can say while root dot right, because we want a maximum element here, is not none. What we can do, we can say root is equals to root dot left, and then finally we will return the root dot val. See, here I am looking for a minimum value. That's why I am exploring the left side. Here I am looking for a maximum value, and that's why I am exploring the maximum value towards the right subtree. This is done. I think we are good to go. Let's try to run this code. If we got some error, we'll try to resolve it at that moment itself. Let's try to run this. एक्सेप्टेड. तो अगर हम यहाँ पे देखें, 3 केसेस पे तो एक्सेप्ट हो रहा है. बट एज आई ऑलवेज से कि लीड कोड में जब आप रन करते हो किसी कोड को, तो उससे ये नहीं समझना है कि आपका कोड भी पूरा वर्क कर रहा है. Until or unless you will not able to submit that code. So let's try to submit this. Showing some error. Showing some error. What it is saying? It is saying that none type object has no attribute right. Okay. Anyone who can let me know what's the issue here? Oh, we need to move ahead towards right side, right? Maximum value निकालने के लिए. Let's try to run this again. Let's submit this. Working perfectly fine now. So by mistake, I have mentioned here root dot left. रूट डॉट लेफ्ट नहीं आएगा, रूट डॉट राइट आएगा, क्योंकि हमें मैक्सिमम वैल्यू निकालना है, राइट. तो मैक्सिमम वैल्यू निकालने के लिए अपने को राइट सब ट्री में एक्सप्लोर करना पड़ेगा. सो दैट इज द थिंग विच वी रियली वांट टू डिस्कस हियर. नाउ इफ यू विल ऑब्जर्व हियर, व्हेन वी आर डूइंग डिलीशन पार्ट, ultimately we are doing a searching first of all, whether we are moving towards the right subtree or we are moving towards the left subtree, right? So you all know that searching depends on big of h, height, which is from logarithmic if it's a balanced BST and a linear one if it's an imbalanced BST. So if I'll talk about the time complexity part, so obviously again you will say that it depends on the height value. If it's a balanced one, if it's a balanced binary search tree, that height will be logarithmic, so it will be big of log of n. If it's a imbalanced BST, now what is balance, what is imbalance, I already have a great discussion in the last session. So if you are new here, please go and check it out. But yeah, it again depends on the height value, because we are doing a searching first and then we are traversing towards the successor or the predecessor part. So again, it all depends on what is the height of my tree, that only times I'll traverse. So that is how basically we will be able to get the time complexity part. Let's talk about the space complexity part. So are we using any extra space? Not at all, right? We are not using any external data structure here. So it will be a constant one. So this is the overall idea which I really want to give in today's session. That is how the deletion can be done. So firstly, today we have discussed logically via the blackboard. I have shown you the conceptual part. The two cases are very important to understand. First case is the leaf node case, where we want to delete a leaf node. Second case is the non-leaf node case, where there are two options we have explored and I did the implementation of both of them, successor as well as predecessor. So I hope it is pretty much clear to everyone. And at the very end, we have talked about the complexity part. So as I have mentioned, the time complexity, again, because we are doing a searching first and then exploring the two ways, it will be big O of h, depending upon whether the tree is balanced or imbalanced. And the space complexity. Okay, one more thing. It's not constant actually, because we are using a recursion here. I forgot this thing. So it should be depending upon, again, big O of h, right? So it's not constant. It's because we're using a recursive space here, it's not constant. Again, it depends on the value of h. How much height is there, that many recursive function calls you will do, right? So because we're using a recursion, so there will be a stack space which we are using. So it should not be constant, right? I hope this picture is pretty much clear to everyone. People usually feel that deletion in BST is very, very difficult concept. And that's why in an interview, this question is very widely asked. Many people don't know the concept of deletion. They know how we can do insertion in a BST because it's very easy. They know how we can do a searching in a BST. Again, it's a very easy concept. But deletion requires a little bit more in-depth knowledge. And I hope that this session gives you a better clarity. If you still have any sort of doubt, I am here for next 4 or 5 minutes. If you have any feedback, any comment, anything you want to share with me, any other question you want to ask apart from this session, I am here for next 4 or 5 minutes. You can ask from me. Otherwise, I can wrap up this session and we can meet another time. So can you guys give me the confirmation, is this clear or not? Or if you have any sort of doubts, I'm waiting for your concerns for the next 5 minutes now. Then we will end this session, okay? It's my humble request from all, that's why this knowledgeable channel have less subscribers. Please share this channel among your group to get the best use for everyone. Thank you, Ankit, for this humble request for everyone. It means a lot to me, okay? Uh, I continue my machine learning part, but can't get any internship. If any opportunities there, please help me. Sure. As of now, I'm also not aware about any as such internship opportunities. But yeah, you can check it out on the LinkedIn jobs thing. If the opportunity is there, definitely you can try to explore. If in my connection there will be any opportunity, I'll definitely let you know. Or maybe I'll do a LinkedIn post also, so that everyone will get to know and will be able to apply. Okay. Perfect. Any other concern? Any other doubt? Anyone? Karan is saying all clear, whatever you are taught right now. Perfect. Amazing. You can also give me a feedback in the comment section, those maybe who will watch after this live. I'm looking forward that what is the next live you want to see with me. Whatever the topic name with respect to DSA or data science you want me to cover up in the YouTube live, you can suggest me the topics in the comment section. I'm looking forward to that as well. And apart from this, the notes as well as the code file, I'll try to upload it in my GitHub repo. And then in the description of the video, you have the URL. You can just click on that and you will be able to get the notes as well as the code file of this session as well. Please do share this video with everyone, as Ankit already requested as per my side as well. Right? And I'll see you all very soon in the upcoming live, where we'll do amazing results, amazing things, right? Trees and graphs. Current for the trees and graphs, I think I already have a video in my playlist. So I really want to look upon for those content as of now, which is not there in my playlist. For example, trees portion is there, graphs are there. So maybe something which is not there, I'm looking forward to that suggestion. Even for the same thing is in machine learning and data science, whatever content is uploaded, it's there. So I don't want to repeat that content. If there is something you think that it's not there, it's not already uploaded, please give me something new and fresh, so that everyone will enjoy that content, and it's something which is freshly available for everyone. And no repetition or no duplicacy is there in the YouTube channel, right? So with this, uh, let's end today's video. I really enjoyed teaching you all, and I hope the same with you all as well. I'm looking for the feedback in the comment section, right? And do share this video, do subscribe to my channel. It's my humble request. It really means a lot to me. It really helps to reach to the wider audience, which I really want from this channel as well. And bye bye. Take care. See ya. Good night.